Dear friends, welcome to Infos. Welcome to another video from Infos Oil and Gas Training. We are continuing our effort to complete pumps. This is our pump part 2, 60th video. So, principle of operation of centrifugal pump. Welcome to this video. Working mechanism of last session we have studied about basic principle of the pump. Now in this video we will just go through it, what are the different operation principle, how the centrifugal force is coming, and what are the basic equation in centrifugal pump, and then how what is the importance of priming, and before starting what are the safety procedures are there, etc. We will look into. Welcome to this video. Working mechanism of centrifugal pump. A centrifugal pump is one of the simplest pieces of equipment in any process plant. It is its purpose is to convert energy of a prime mover, electric motor or a turbine, first into velocity or kinetic energy, and then into pressure energy of a fluid that is being pumped. The energy changes occur by virtue of main parts of the pump, the impeller and the volute or diffuser. The impeller is a rotating part that converts driver energy into kinetic energy. The volute or diffuser is the stationary part that converts kinetic energy to pressure energy. So that is an important point. You have to understand that one. The impeller is the rotating part that convert the driver energy into kinetic energy. So impeller shaft is connected to driver shaft. So that is driver energy to kinetic energy. Then the volute or diffuser is a stationary part that convert the kinetic energy to pressure energy. So it is a simple picture is there to see the impeller, outlet discharge, inlet is there, outlet discharge volute is there, and the impeller is there. See, impeller vane, driver shaft eye, and volute casing, etc. Simple centrifugal pump pictorial representation. So generation of centrifugal force. The process liquid enters the suction nozzle, then into the eye center of a revolving device known as an impeller. When the impeller rotates, it spins the liquid sitting in the cavities between the vane outward and provide centrifugal acceleration. So always impeller is rotating with connected the shaft by receiving the power energy from the driver side, and when the impeller rotates, it spins the liquid sitting in the cavities between the vane outward and provide a centrifugal acceleration. As liquid leaves the eye of the impeller, a low pressure area is created, causing more liquid flow toward the inlet. Because the impeller blades are curved, the fluid is pushed in a tangential and radial direction by centrifugal force. This force is acting inside the pump is the same one that keeps water inside a bucket that is rotating at the end of a string. So same, it is turning like that one, like this one turning. The same force is acting like that one. So it is ultimately it will leave it to the discharge vane. Discharge nozzle, discharge side outside. Conversion of kinetic energy to pressure energy. The key idea is that energy created by the centrifugal force is kinetic energy. The amount of energy given to the liquid is proportional to velocity at the edge or vane tip of the impeller. The amount of energy given to the liquid is proportional to the velocity at the edge or vane of the tip of the impeller. The faster the impeller revolves, the bigger the impeller is, then the higher will be the velocity of the liquid at the vane tip, and greater energy is imparted to the liquid. So impeller is running more fast, and the bigger size, more liquid will take, and the velocity will be more. This kinetic energy of a liquid coming out of an impeller is harnessed by creating a resistance to the flow. The first resistance is created by the pump volute casing that catches the liquid and slows it down. If the discharge knows it, the liquid further decelerates and its velocity is converted to pressure according to Bernoulli's principle. Bernoulli's principle we have studied in school. Therefore, the head pressure in terms of height of liquid developed is approximately equal to the velocity energy and the periphery of the impeller expressed by the following well-normal formula: H is equal to V square by 2G, where H is equal to total developed head in feet and velocity V is the velocity at the periphery of the impeller feet by second, and G is the acceleration due to gravity, that is 30.2 feet per second square. So this is the well-known equation. So a handy formula of the peripheral velocity is V is equal to N into D by 229, where V is the velocity at the periphery of the impeller feet by second, N is the impeller RPM, D is the impeller diameter. So conversion of kinetic energy will continue to pressure energy. This head can also be calculated from the readings on the pressure gauges attached to the suction and discharge line. One fact must always be remembered: a pump does not create pressure, it only provides flow. Pressure is just an indication of the amount of resistance to flow. This is very important. Gas we are compressing and increasing the pressure, but for the liquid pump we are using and it is providing flow, and pressure is just an indication against resistance of flow. That is important. A centrifugal pump takes in energy from prime mover, which drives and it converts this energy into pressure energy within the liquid being pumped. The pressure developed at the rate of flow of the pumped liquid will depend upon the design of the impeller, that means diameter, width, shape of the vane, and speed of its rotation. So these are the important basic principle of the centrifugal pump. Then we will look into what are the operation conditions and safety features of centrifugal pump. We have to keep some safety features, safety points inside our mind before going to operate it to understand the centrifugal pump, because most of the centrifugal pump in our classes we are taking in oil and gas industry, hazardous, toxic and flammable environment. So we will be considering safety features as well. So some of the more important safety rules that apply to the pump operation include the following: know what sort of liquid being pumped, very important. So specific gravity of the liquid, vapor pressure of the liquid, and temperature of the liquid. So pump safety is very important. Look at that one. Observe proper purging precaution. Normally in previous class also, I remember that one in the previous class also, purging and vending, priming also, just to pointing that one in that previous class, because the liquid or air trapped inside the casing, we have to remove that one. Then only we can, the pump filled with the pumping liquid, then we are pumping. Look at this picture, it's a casing vent is there and the casing drain is there. So you can remove that one, any air or hydrocarbon gases are trapped inside the pump casing and the suction side and discharge side. We can slowly vent it, and any unwanted liquids are there in the pump casing bottom side, we can drain, we can do that one. So this is very important safety point of view before starting a centrifugal pump. Venting vapor from casing, suction line, discharge line, and wherever necessary. When pump vent directly to atmosphere, the operator should stand clear as the vapor is being purged. The vent valve should be only cracked and not fully open at the start of the purging. Only crack open and see that one any trapped vapors are leaving from the pump casing. That is a safety one, number one, purging and priming. Sorry, not purging and draining and priming. Then protective guards, it's a rotating machine. So it's very important, protecting guards are very important. Guards are fitted in the shield against accident, and the pump must not be operated unless all guards are secured in place. Maintain correct lubrication. So it is a rotating machine. Lubrication and sealing systems are very, very important, and cooling system as well. Checking the correct lubricant levels before starting. Tidiness around the pump area is very important. After any mechanical work or some other maintenance work, the cleaning of the area, hygiene is important. Safety, housekeeping is also important. Free area around the pump, not rubbish and debris. Any spillage or lubricant should be immediately cleaned up. So let us place the pump back. A pump that can be out of service for a given period must be properly placed back in service before it may be started. So check the safety hazard. What are the safety point of view? What are the hazards are there? We have to eliminate that hazard, minimize that risk of that safety hazard. So we have to read it and understand that procedure before starting the pump or taking into operational from long shutdown or maintenance. Checking lubricant level and cooling water flow. Checking, purging and priming the pump. If positive suction head is available, then the pump is purged as follows. So this is the suction tank, this is a suction valve, this is the discharge valve, you can say, this is the priming venting valve, and this is the recycle line. So it is all valves are closed now, and the suction is tank is filled with liquid. So it is now the vent line is open. So whenever you have getting a time to visit your area for a centrifugal pump, see that one how the priming is doing. So that will give very good confidence to do the job. So the priming venting valve will crack open. So whatever the vapors are going, then you will open little bit, then it will close. Sorry, not keep it open, and then the before that the second this one is a recycle line is opening. Then open the suction line, crack open. You can open that one, slightly filling the liquid inside. If it is, imagine that one hydrocarbon liquid, slightly it will come up, or you can see that one it will come the here this area, you can see that one slowly. Then close that valve and open the, it will recycle lane is full. So now it is the pump is fully filled with the hydrocarbon liquid, and no air is trapped inside, air or hydrocarbon gas or unwanted. Some pumps are connected with the drain lane also. In earlier picture I have shown that one. So earlier picture also drain also you have to open and release the contaminated water or liquid. Then it is filled with water. Now you can start the pump. Now pump is ready for starting. If the pump is operating in a suction lift, negative suction head, then the pump must be purged and primed using one of the following method. If there is liquid at the discharge side of the pump, then the pump can be purged and primed by opening the discharge block valve and also suction block valve. When the liquid is not available at either suction or discharge of the pump, then the liquid must be pumped into the pump casing and suction line from another source by using an auxiliary pump. Resetting the pump circuit breaker and lining up the pump. So these are the pump starting, before starting, pre-startup procedure you can say. Starting up a centrifugal pump involves the following step. Close all drains and vent line after priming the pump. Check that the forced feed lubrication, seal oil system and water cooling systems are fully operational. Open the suction block valve to its fullest extent. If the pump is being started to relieve another pump, then open the discharge block valve fully. That means if other pump is working like a pump A, it is working, then we are going to start pump B. Then we are switching off pump or shutting down pump A. So in that case, another pump is existing, running is there, then you can open the discharge block valve fully. If however the flow will be enough, flow will be through a line that has been out of service, then the discharge block valve should only be opened. So if no other pump is there, the fresh one pump is starting, then discharge block valve will be in closed position before starting the pump. Press the pump start button or switch at the and check for increase the lube oil pressure. Gradually open the discharge block valve if it is not already open in section 4. Check the discharge flow controller of the desired flow rate and make any adjustment and set point may be necessary. So that is a startup procedure is there. In that procedure, these procedures are describing in detail. So you can read that one, you can try that one, you can assist the main operator for 1 or 2 times, you get knowledge or understanding, experience on how to start the pump. Monitoring operation of the pump. After the pump has been started and running for several minutes, the following check should be made to make sure the pump is operating normally without any problem. Monitor discharge pressure for abnormal values, monitor the suction pressure and discharge pressure. What are the set points are there normally keeping operating value? You have to check that out. Any abnormalities are there, please note down. Recheck lubricant level. Check operation of force feed lube system. Check for excessive motor temperature. Check pump bearings and packing for excessive temperature. Listen for abnormal noises. Check for excessive vibration. That is also very important. These all points are very, very important. You have to take care for while startup or changeover of the pump. Check packing or mechanical seal for excessive leakage. Switching the pump. Switching pump like 2 pumps are working A, B, or 3 pumps are working like that one A, B, C. In 1 pump is running, 1 pump is standby. So switching over pump is also like an important procedure like shut up and shut down. Switching pump involves shutting down one of the pumps arranged in parallel whilst the same starting up a relief pump. Since it is important that the load be switched from one pump to another with the least possible disturbance to the process, switching should be carried out by 2 persons. One person shut the pump to be taken out of service whilst the other person start the relief pump. Normally in oil and gas, from our experience, what we understand that one, we will start the pump, then we will switch off the pump next step, because otherwise it may disturb the process operation. So these are the simple explanation that one. This is a tank and this is a feeding pump, and these are the suction discharge lines are there, and these are the pump we have to change over. Standard switching the pump procedure will be there in each operating plant. We have to read and understand that one before going to do the job. Securing a pump maintenance. When a pump is to be taken out of service for a maintenance, the following steps should be carried out. The running pump now we are going to take in maintenance. Earlier, the maintenance pump, the pump is taken back to service after maintenance. So so now it is a pump is running before going to maintenance. What are the important steps we have to carry it out? Shut down the pump using stop button or switch. If necessary, the process should be switched to a standby pump. Isolate the electrical supply to the pump by tripping the circuit breaker in the switchgear building, then securing it in the open position with a padlock or attaching a warning tag. As an additional precaution, check the pump does not start when its start button is pressed. Normally, pump is taking to maintenance. We will release the circuit breaker, that electrical energy is isolated. Then we will use a lock and pad system. to prevent unauthorized starting electrical energy is energized. So this is the electrical safety procedure. If you know that one, you have to read that electrical safety procedure available in your plant. So that will give a clear understanding on how electrical energy isolation and de-isolation procedure. An additional precaution, check the pump does not start when the start button is pressed. So preventing accidental startup of the pump. Close completely both the suction and discharge block valve. We have to, mechanical isolation is very, very important. Open the vent valve to allow the liquid pressure inside the pump reduced to atmosphere. So just venting that one, slowly crack open. Open the drain valve, usually located at the bottom of the pump casing, and allow the liquid to drain off to the closed drain. Close the drain valves after the liquid has been drained off the pump. So pump is clean, pump is released, electrical energy is isolated, mechanical energy is isolated, suction discharge valve closed, vent valve is open and release the pressure, then it is closed, and drain valve is open and release the hydrocarbon liquid available inside the casing. So it is ready for the handover to maintenance department. Any other procedure is pending, you have to complete that one, and cooling water system, lubrication and seal oil you have to isolate. So these are the common and general steps, and you have to take care for any other steps are there in the procedure. Please do it and read it 1 or 2 times. Tag the pump for repair. So locking and tagging will be there. Safety note is there. A pump which is locked out of the switchgear building or tagged for repair should never be restarted without first checking that all work on it has been completed and a permit to restart has been issued. This is a very, very important safety procedure. Thanks for watching this video. I hope that when you will understand some of the key information of the centrifugal pump startup and safety procedure and changeover of the pump precaution for what are the important parameter to monitor in the pump operation, and maintenance, how to take into maintenance pump to change hand over to maintenance department. These are the simple and important information we have reviewed today. I hope you have to understand that one. Thanks for watching this video. Have a good day.